Okay, so today we are going over Postgres, which is also like spelled like Postgre and then SQL. Um, what is Postgres? Postgres is a relational database management system, and what that essentially means is it is a service that can manipulate databases and the relationship between like rows and columns and other fields within the database. So you might have heard of like some other relational databases. Uh, like one of the most common ones is MySQL or MySQL. There's also like Microsoft SQL and Oracle. There's an Oracle database, which are all relational database systems. Um, but Postgres Postgres and MySQL are the primary databases that are scored by CyberPatriot, and we already went over MySQL during our LAMP presentation, so we'll be going over Postgres today. Um, to set up Postgres is very simple. All you have to do is install the PostgreSQL package using the apt-get install command, and afterwards you can just start the service, but it should already be running, but you can access or you can restart, stop, and start the service under the name PostgreSQL with the service command. And then all of the configuration for Postgres, so essentially all the securing that you'll do will be in this location of the config, which is etc PostgreSQL. And then there's a 9 period, and this X will be replaced with whatever version number you install, depending on like how updated your repositories are. And then main. So this is the directory where all of the config for Postgres will be, and I'll go over what each file does in the next slide. So the pg_hba.conf file, this is the first file that we'll go over and how you can secure it. Essentially what it is it is the client authentication configuration file. And what that means is it has a number of roles in what it can configure. The first thing they can do is it can decide which hosts are allowed to connect. And when I say host, I simply mean like a computer or a server or some kind of connection. A connection typically will come from a host, and that's how I'm using the term in this context. Um, how clients are authenticated. So if say like you connect to the database, this pg_hba.conf file will also determine how exactly you should authenticate yourself, which Postgres users can be connected to. So the Postgres database and most other relational database management systems for that matter will allow you to create users and create roles and grant them assignments, um, which you don't really need to know for the purposes of this competition, but what you can know is that when you connect to a database, you connect under a specific user. So this file will determine which users you are allowed to connect to. And finally, which databases can be accessed. As I mentioned before, uh, like systems like Postgres and MySQL, they can like manage not just one but several databases, and you can specify which ones you can connect to in this pg_hba.conf file. So the file looks like this. This is a screenshot of, I believe, the default configuration. Um, you can see there are 5 columns here: type, database, user, address, and method, and they're separated by like tab characters. So this first column, type, that specifies what type of connection it is. So you have a local connection. Hold on, give me a second. So you have a local connection, which essentially is just like a Unix domain socket on your own like network. And then there's a host connection, which is like the typical connection that you'll get from either like a TCP IP socket or something like that, or like a UDP connection. Um, and that can either be like a plain or SSL encrypted socket. And then host SSL is, as you can see here, and on this slide, I have like the ideal configuration, bolded, underlined, and in the color green. So host SSL is the preferred method of connection type, because what that does is it only accepts connections from an SSL encrypted TCP/IP socket, as opposed to a plain TCP/IP socket, which would be specified by host. And SSL, if you don't know about it already, we've covered it in a number of meetings, but SSL is simply the secure socket layer, and it serves as like an encryption for TCP/IP connections and UDP connections. Um, the second column, database, as mentioned in the previous slide, this file can determine which databases you connect to. So the two primary specifications of this column will either be all, referring to every database on the server, or you can specify the actual name of the database using just writing out the name. And then the next column, user, similarly to database, the database column, you can specify all, meaning that any user on the Postgres database can be connected to, or you can list out the specific usernames. I think it's separated by commas also. Um, and then address specifies what the host address or set of hosts uh, this connection can come from. So you can see in this screenshot, you have 127.0.0.1 and then /32. This is in slash notation, and the /32 is the subnet mask, which specifies like the entire set of hosts that this refers to. And then the 127.0.0.1 is just the default gateway. And then the method, which is and also in this other example here on the final line of the screenshot, you see there's 2 colons and then 1 and then /128. So this is simply an IPv6 address. So this example here is an IPv4 notation, but this is an IPv6 address, which you don't really need to concern yourself with, just in case you're curious. And then the final column, which is method, essentially just determines how clients are authenticated. So it can take on a number of arguments. There's trust, which indicates that uh, any like any connection from this place or user or whatever will simply be authenticated without any question. So it's generally very insecure because you typically do not want to have no systems of authentication in place. And then reject will simply deny the connection no matter what it is, or if it fits under like the host address and to the user in the database and the type, then it will deny or it will reject the connection. And then MD5, as you can see, I have it in green and underlined and stuff here because this is the preferred method for this last column. And what that does is it sends encrypted passwords in the database connection to the server, compared to this password argument, which sends the passwords in plain text, which is very insecure. So you would like to have it encrypted, which is why MD5 is the preferred method. Okay, the next thing that you'll have to do, in terms of like, or actually here, so I'm gonna stop sharing my screen and I'm gonna go through each of those things one by one, in the VM. Okay, so as you can see, I'm in my VM right now. I'm in my home directory. As mentioned before, so I already have Postgres installed, but like I said, you could just go about installing it just with this command. Okay, well, I think I'm doing some kind of update right now, so I can't. But and then service status all, which lists all the services, and then I can just grab for Postgres and see that it's running right now, or I can do sudo service PostgreSQL status, and everything looks good. It's active, so I don't need to start or restart or anything. And as I mentioned before, the location of all the configuration files is in etc, and then PostgreSQL, and then I can ls to see what version I have. So it's 9.5. So I just cd into this directory, and then I cd into main, and here is all of the configuration essentially. So let's edit the pg_hba.conf file, which is what we've been talking about. Um, okay, so there's a lot of comments you can see. Okay, so this very first line, as mentioned earlier, you typically want to have the connection type as host SSL for any instances of host. So here you can see the type of this first and second connection. Both of these queries are for local connections, therefore we don't need to modify them probably. But if we look at the very last method or the very last column, which we also said should be MD5, in this case we don't need to modify it because peer a peer method is a completely different type of authentication protocol, and for local connections it goes somewhat differently than typical TCP/IP socket connections. So we don't need to modify anything on this line. What you should look for when you're editing this file is any instances of host you should replace with host SSL, and any instances of trust or password you should replace with MD5. So if we look specifically for that, in this third line we have host as the method. So we'll immediately just want to change this to host SSL, meaning it only accepts uh, in, in, it only accepts connections that are encrypted with SSL, as mentioned earlier. Um, these next three columns we can ignore essentially, because there's nothing wrong with connecting to all databases or all users, and also the address is arbitrary pretty much. But then the final column has trust as the method, which we don't want because that allows connection to the database without any form of authentication. So we're going to change this to MD5, and then sort of like the same thing for this next line. For IPv6 connections, we're going to change host to host SSL. These next three columns we can ignore. And then the final column, the method, we should replace trust with MD5. There we go. So now all of our connections and queries are all secured. Okay, so let me change screens back to the slides. Okay, the next thing that we want to do is encrypt the Postgres database with SSL. And the way we do that, we first start off by generating an SSL certificate. So unless the README tells you that there is already a certificate that they have in some directory, then you should generate your own self-signed certificate. And the way you do that is with this big command. If you've like listened to any of our other service lectures for Linux, at least for like ProfTPD, VSFTPD, PHP, Apache, then you should be familiar with this command. This is exactly the same command as like all those other services that you would use. However, the only difference is where you're outputting the key file, which is specified after the -key out flag. So we're putting that in etcssl private and then postgres.key. And then the file of the actual certificate goes in etcssl certs postgres.crt. So the only thing we're changing from those other implementations with ProfTPD or VSFTPD or Apache is that we're changing this name of the file to be specific to Postgres, which obviously the name is also arbitrary, but now it's like more specific. So our certificates can be more organized. So you should definitely write this down somewhere if you haven't already. You could also probably get it from just Googling like how to generate self-signed SSL certificate, but I would recommend you write this down or screenshot or something. Um, so once you have this SSL certificate, then you can go into the PostgreSQL.conf file, and here's where like the I guess the primary configuration of Postgres is, like the very general configuration. The first line that will change is listen addresses, and set that equal to localhost. Uh, Essentially what this does is the server will only listen on the default gateway, which is the localhost, meaning it's not listening on like some external connection. which you should not do if the server is relied upon by another service. For example, like there might be another server, like a web server, running on Apache or something, and that might require the database. So you might want to listen to that Apache web server. This is just a very like random example, and it'll obviously tell you in the README if this is the case. In which case, you would change the listen addresses to whatever the specific IP address is. But for the most part, for all the online rounds, you will 99% of the time just leave it at this listen addresses equals localhost. The next line is enabling SSL with just this SSL equals true. Make sure it's not like anything else like SSL equals yes or SSL equals 1. Even though these kind of look like they're enabling it, they're not. The only way it enables itself is SSL equals true, like word for word essentially. And then SSL cert file, we set that equal to the direct or the output of the file which we generated in that last command. So if I go back here, so we're setting the certificate file to be at etc ssl certs postgres.crt. If we go back to the previous slide with that long command, we can see we have the exact same directory here, which is specified after the -out flag, which is where we're storing the certificate. And same thing with the key. We set SSL underscore key underscore file equal to etc. Okay, this is wrong. First of all, whoops. I believe it's just, it's /private. Sorry about that. But so the key file should be pointing to this directory of etc SSL private postgres.key, which matches up with the output of the key, which we specified in this command, which is etc SSL private postgres.key. So that should all be pretty intuitive. And the final thing we want to do is log all connections, which is pretty self-explanatory, but just set that equal to on. Okay, so now I will show you exactly what that looks like in the VM. Okay, so as mentioned in the slide, the file that we're editing is postgresql.conf. Oh wait, but before we do that, we need to generate the SSL certificates. So I'm going to copy this command that I had on the slide and paste it here. Okay, well I need to do it with sudo. So when you're generating a certificate, as I said earlier, the process is exactly the same for any other service that uses SSL. But all you have to do is like, you can just click enter through all of these. You can keep them all blank and it doesn't even matter. And there's no like confirmation, but it was actually outputted to the directory that we specified. So, okay, you need to have root access to actually view them. But so as you can see, I just listed out all my keys on this server, and we have postgres.key, which we just outputted. And if I go back a directory and into the search directory, that's a much longer, but if I just grep for Postgres, we have the Postgres certificate right here. So it looks like the command worked properly. Now I'm still inside this PostgreSQL main configuration directory. And like when I list the files again, you can see that the postgresql.conf file is next to the pg_hba conf file. Like all the main configuration is right here. There aren't any more like subdirectories. So I can just edit this file directly. So as mentioned before, the first thing that will change is listen underscore addresses. You can comment it out, or you can uncomment it if it's commented out, and set it to localhost, which is also the default, by the way. So if it's not localhost, then that should be somewhat of a red flag to you. Then SSL equals true. Right now it's at SSL equals false, so we'll definitely want to change this. Then we can just look down here a bit, and then as you can see, it's already pointing to some certificate files, but we want to just change it to the ones that we generated ourselves. So certs postgres.crt, I believe, and then change the key file to postgres. What is it? .key. Yep. Okay. Um, and then the final thing that we need to modify is log connections. So it's at off right now, so we'll set it to on, and nice. Now we are done with the PostgreSQL.conf file. Okay, and the final configuration file that we will be modifying is this pg_ident.conf file. What this file does is, or what it can be exploited for rather, is it can grant unauthorized users privileged roles in your database. The primary function of this file is actually like user mapping. And what that means is if you like connect under the username of like Jeff on your host machine, then this file will map your user to a specific Postgres database user for whatever reason, which can be exploited to give some kind of unauthorized user or more privileged account on the database, like the root user, for example. So that's why this file can pose as a security risk. And all you have to do to configure it is ensure that the file is empty, because you shouldn't have any maps, any user mapping, unless unless specified in README. Because the README may give you some kind of uh, like prompt that's like map user Jeff to the root user on the Postgres database, in which case you should know to look in the pg_ident.conf file. The key word is user mapping. So like if you see something related to user mapping inside a README and Postgres is one of the scored services, then you can almost be 100% sure that it's referring to this pg_ident.conf file. But if it doesn't have anything related to user mapping in the README, then you will need to ensure that the file is completely empty. And what the file looks like, it's just separated by lines in the format of this first field, which is called map name, and then separated by tabs, system name, and then database name. The map name is like completely arbitrary. It's like the equivalent of naming a variable. It's just there so that you can reference to it in other files if you need to. Um, the system name is the actual name of the user that you want to be mapped. So not mapped to, but this is the user that you want to be mapped. And it will refer to the system username of that user. And then database name is the username within the database that you want to map the designated user to, if that makes sense. So for example, if I have like um, Bob as the system name and then Jeff as the database name, then I will want to map any user named Bob to the username Jeff in the Postgres database. So let's go back into my VM. All right, so once again, this pg_ident.conf file is in the same directory as all the other configuration, which makes it very convenient for us. So if I just scroll down here, you can see we have a map. So I mean, I obviously want to delete it anyway, but just in case also there is like a forensic, it may be useful to understand the contents of this file. Like if there's a forensic question that asks like what system user is being mapped to the root Postgres user, then you could say Bob, for example, in the forensic question and get points for that. But yeah, so I mean, there is a map here, so we're going to delete it anyway. But what this map is doing exactly is, so it's called my map, which as I said is arbitrary, but that's the name of this map. And then it's mapping the system user of Bob to the Postgres user root. So, I mean, you can obviously tell that is very unsecure because you don't want to you don't want to be mapping any regular users to the root user. So I'm just going to delete this line. One thing you might encounter in this competition, because like Cyber Patriot likes to troll a lot, is they could just like create a bunch of new lines and then remake the entire map, and then it's just down here. So you open the file and you see that it looks empty, but it's actually not. So what you might want to do to combat that is just like completely empty out the file Um, I'm trying to delete all these new lines. Okay, there. So what you might want to do to combat that is just echo nothing to the pg_ident.conf file. But as I said before, like it's a possibility that there's a forensic question about that. So obviously make sure that there's nothing asking about a specific map before you clear out the file. Or you can just like notice that there are a bunch of other lines in the file and then just scroll down. Okay, so there's another slide for this, but I can just tell you what it is. So the final step that you have to do to like configure Postgres correctly is you just need to restart the service, and uh, that will essentially like apply all the changes that you made to the pg_hba.conf file, the postgresql.conf file, and the pg_ident.conf file. So it's very important that you restart the service in order for all of your changes to be saved. And that is the entire presentation. If there are any questions, you can ask them.